Hey there, AP Chem Scholars. Today we go on to Unit 3, Section 9, Separation Techniques. We've been talking about solutions and mixtures in the last sections. Now we're going to talk about how to break them back down. All right, so let's jump into this. Obviously, one of the ways that you're probably most familiar with is the idea of filtration. Okay, so filtration, I don't know that I really need to explain. Obviously, we're using some kind of a filter to separate a fluid to catch a solid. Now, I'm emphasizing fluid because it doesn't have to be a liquid. You might have filters in your house on your heating system that are designed to catch dust and whatnot, so it lets the air flow through and catches that. So it does not have to be a liquid. Please keep that in mind. The fluid that passes through the filter is called the filtrate. That term we might not have used before. The solid left behind is called the residue. All right, not too much fancy about that. Another thing we may have done along the way is the idea of evaporation. I know at one point we used a drying oven to evaporate some solutions for you in the past. Same idea, okay? We gently heat something to separate a solution, in this case, to allow the solvent to vaporize, leaving the solute behind. Yes, you could use it to separate a heterogeneous mixture as well, but there are probably easier ways to do it than that. All right, so I forgot to emphasize that when we were talking about filtration, I'm going to backtrack, sorry, but it's like I'm in class, you know, these things happen. This is technically separating a mixture, not a solution. The idea of a solution should pass through. So if we had salt water and sand mixed together, the sand would get stuck, the salt water would come through. Okay, so that's important to keep in mind. Okay. All right. We have not done this, okay, but we have talked about doing decanting, which works off of the same idea technically. When you're decanting, you're pouring a liquid off of a solid, okay, because the solid should sink because of its greater density. That's what a separatory funnel is about. We put in immiscible liquids and we let them separate according to density. So the higher density liquid goes down, the lower density one. Then we could open up the tap and just let a little bit out at a time of the higher density liquid, and eventually we can separate the two of them that way. Obviously, it's very difficult when you get to that interface boundary where the two liquids are coming together, but it would allow you to very easily separate the majority of it without any issues. And then at the end, you'd probably have to separate out the beaker, put another beaker in, and if you don't, as you're getting too much of the low density liquid, you just pour it back, let it settle, try it again. Fractional distillation works off of the same idea as evaporation, except now we're talking about separating liquids by different boiling points, by distilling them. Okay, distillation is the process of boiling and collecting a liquid. Fractional distillation means that we're going to have different substances that will boil or evaporate at different temperatures and rates, and we're going to basically try and separate one at a time this way. So, for example, if we put acetone and water, not acetone, alcohol, ethanol and water, they mix very well. Actually, they do talk about acetone and water here. So we'll stick with that. If we're doing acetone and water mixture, okay, acetone evaporates much easier than water, so a very low flame would allow the acetate to start evaporating, which would move it up through the fractionating column. The fractionating column is there to help separate out the different materials, because even though we know that the acetone is going to evaporate first, water is going to evaporate a little bit too, and the fractionating column would be designed to help catch the water molecules but not so much the acetone. So you would design a fractionating column according to the type of materials that you're working with. And then from there, the acetone vapors would go up to the top, but because of the cork, they're forced down into this condensation column here. So we have a water condenser where we would run cold water through this, and it would come out here. So you would just connect tubing to it, and that'll help to cool the acetone gas back down and causing it to condense into a liquid, and so we would collect it there. Okay, so it literally is the idea of, evaporating and then condensing it, which is what distillation is all about. Now, an important lab that we're going to come back to is the idea of chromatography. Chromatography, again, I'm going to have to use that phrase that you're probably hating to hear by now, like dissolves like. Okay? Chromatography is a means of separating mixtures. Typically, we're talking about in the liquid phase, although there are different types of chromatography. And what would happen is you would put, this is called paper chromatography, again, what we're going to focus on. You would stick this piece of paper with some ink spots on it in a beaker with some solvent. And what's going to happen is capillary reaction is going to draw that solvent up, and the solvent's going to move. And as it moves through the ink spots, it's going to pull the dyes that are making up that ink along with it. And the ones that are more similar to the solvent are going to travel further. The ones that are less similar are not going to move as much. Okay, so we cause a separation of them according to how similar they are to the solvent. Now, there are two ways to go. Okay, we could use a polar solvent, in which case you got to make sure that the paper is nonpolar, or vice versa. You could use a nonpolar solvent, but then the paper has to be polar. Okay, so the solvent is usually referred to as your mobile phase because that's going to climb up the paper, but the paper isn't moving anywhere, so the paper would be called the stationary phase. So if the solvent was polar, I would say that this substance is pretty polar, where the blue is somewhat polar. Okay, so we can evaluate the different materials that way, and also by collecting actual data as far as how far a dot moved compared to how far the solvent moved. That's called, well, we'll come back to it, it's called the retention factor. That will allow us to help identify the different dyes that are in a substance. And we are going to be doing a virtual lab on that soon. So that gives you kind of the idea of what's going on there. Like I said, there are many types of chromatography, okay? But we only talk about paper, and we'll mention maybe thin layer chromatography, but it's pretty much the same thing as paper because it works in the same plane. And here's the idea of that retention factor. It's called an RF value. We're talking about the distance traveled by one of the dyes or one component compared to the distance traveled by the solvent. So it's just a ratio of how far this moves compared to how far the solvent moved. And obviously, the closer that ratio gets to 1, the more similar the intermolecular forces must be between the solvent and whatever dye we're talking about. All right, that'll do it for today. That was a nice short one, right? Yeah. All right. Peace out, yo.